Okay, today we are going to talk about class-to-class relationship, okay? Class-to-class relationship. And previous one, we talked about object-oriented programming. So object-oriented programming, we have the two branch. One is the class design. Class design is design one class. And then the other important knowledge is the class-to-class relationship. So you have two class. What is the relationship they have? Okay. So last session we focus on single class design. There are three important guidelines: encapsulation, inheritance, and the polymorphism. Okay, we talk about it. And today we are talking about class-to-class design. Okay, and then it's important relationship are two major kinds. One is A relationship. The other type is the has A relationship. Okay. So is A relationship and the has A relationship. Now, let's look at it. Okay. So usually is A relationship and the has A relationship. Is A, we also call it inheritance. Has A, we call it association. Okay. How to test it? If there are two classes, we have a car and an engine. Okay, car and engine. So car has an engine. So car use an engine. Okay, car use an engine. So car use an engine. So we use dash line, an arrowhead. Car use an engine. So this has a relationship. Okay. Person has an account, right? So the account is some sort of property for person. So person has an account. Car class and the engine class, it has the also is a part of the car. So actually this has a relationship. And the other one is a relationship. Is a relationship is like Honda car. So Honda car. Honda car is a type of car. So we use a straight line and the solid white head for it. This is a relationship. And then Civic is one kind of Honda car. Okay, so this one is the so-called is a relationship. It's one kind of the car, right? Civic is one kind of Honda car, and Honda car is one kind of the car. Okay, let me check the chip out. Is there some question? Okay, now these are the is A and has a relationship. I would like to demonstrate it, not using Python today. I'm going to demonstrate it with BlueJ today, Java today. Okay, and I picked BlueJ, a high school tool. Okay, a tool used for high school AP course. The reason I picked this tool is that it's actually a more convenient tool for demonstration. And the code later I'll send out by email. Okay, so don't worry. So this one I'm going to create a new directory. And then PyDev, let me put in PyDev. So this one is, let me create a new directory called BlueJ. Okay, inside BlueJ, let me select this folder, call it lecture 6. Okay, lecture 6 project. Let me explain this one. First one that actually has a relationship. Okay. So let's assume that we have a class called baseball class. Okay, baseball class. So baseball, you had a batting order, right? You have batting order, you have players. So let's assume that we have 9 players. So 9 players, I can use array. I can use array. So here, I say, let me create another class called player. So player class, okay, player class. Let's assume this is baseball player. Let's create a simple class. So here, a player may have name. Okay, because we want to have it encapsulation, so let's use the private data field. Okay, so have a name, and then important thing is like double. Okay, batting average. Okay, batting average. I think batting average important. And then what else important? Integer age. Okay, age, personal information. That's assume that we just have this data field, and then it's a player actually constructor for string name double EA and then integer age. Okay, and then let's just have this. Okay, and then here we have is the name equals name. Okay, is the PA equals PA. Is that age equals age. Okay, these are age's name and the batting average. These are the so-called instant variables. And then let's also have a one to string function instead in case that we need that. Okay, to string function, you return string. This one is just to convert a string. Okay, so and this one return, okay, return string that format. Percentage S, okay, percentage W F, okay, and then percentage E, okay, and then name, and then getting average, and then age, okay. So let's assume that this is our player class, and we create a tester player class. Okay, as you can see, when I do OOP, I construct a data entity first, okay, and then construct a tester and put your data class in the center, okay, and then put your tester outside. I use BlueJ because actually it shows you how to develop the OOP better, okay. So public static void main string let's write bracket ARGS, okay. System that out that print, okay. So as you can see, when I teach computer science, I like to teach by coding, okay. Okay, here, so we have a player, okay. Player P1 equals to new player. This is using the constructor to build a user. So let's assume that the name is called Ariel by the alphabet, okay, Ariel, and battery 0.3, age 20, okay, whatever. Let's just try one class. And then we do system.out.print line, just print out is a player 1. Because we have a 2 string function, so the object will be converted to a string, okay? So let's see. What is the relationship of the test player and player? This one for Matthew.
Test player is a player.
Test player relationship to player relationship.
So then, yeah, so the test player is a player, correct? Because test player, when it has it, it would be,
No. Test player and the player has a relationship. Test player has used the player. It use it. So you see it's a dash line error. So in this case, it has a relationship. Is that okay?
okay, that makes,
When you can represent say using use also it has a relationship. Make sense?
yeah, it makes sense.
Test player is not player. It's not a person. It's a tester. But it use player. Okay? Okay, let's look at the baseball team. So this is a baseball team. We have 9 players. So we have a player array of players. Okay, equals new. Okay, player. And we need to have a 9 player. Okay. And then we have a constructor. Okay. And this constructor, we will actually let's assume that actually we have a player array PP. Okay. And then player. Okay. What's wrong with baseball? Invalid method. Return type required. Baseball. Wait, how come?
Do you need to make it void?
No, let me see something wrong. Okay. Player baseball. Did I spell something wrong? Return type needed.
Baseball is with the
Baseball in the
lowercase b.
middle.
Yeah.
Oh, sorry, go ahead.
Jeffrey's got it. The baseball's with the lowercase b for the class, and it's gonna uppercase b for the ball inside the constructor. So it's a misspelling.
Spelling. Okay. Okay.
Yeah.
I'm sorry. Mismatch. Okay, player, this player the same
Oh,
thing.
small p, yeah.
Yeah, I'm sorry. Okay, let's see. Okay, let's actually also create string. Okay. To string. Okay. And then we create a string. Okay, return string equals empty string. Okay. Let's actually have this. Okay. Right side bracket. Okay. And at the end, we will return this R. Okay. So this one, we set up the left right bracket, angle bracket. Okay. And then we are going to put the player list in there. So let's do this one. Okay, let's do this one for integer I equal 0, I less than PP balance. I'm sorry, not players balance. I increase. Okay. If I equal 0, actually R plus equals players I, okay, else plus equals comma space plus players I. Okay, so this one will create a list. Okay, this one will create a list for converting the players to string. So that baseball relationship now is also use A has use the play. It's not use a player. It actually has 9 players. Okay, so this one has a relationship. So has A sometimes use has A sometimes is use. Okay, sometimes is use. So both are has a relationship. Okay, they are using the dash arrows. Okay, they are using the dash arrows. So now let's actually create another class called test baseball players. Let's create another class called test baseball. So you finish the data class, you try to use the tester class to test it. This is the way to develop the object-oriented programming classes. I'm trying to teach more fundamental part. Okay. So now let's create a baseball team. Before we create a baseball team, let's create players array. PP, okay, equals this time let me use a listing. So let's actually use this one. Let's have the this one for new player. Okay. So let's start it from aerial. Patinage 0.3. Okay. Page 20. Okay, let's actually just copy. I'm sorry, this one should be a comma. Let me copy 9 times. Okay, copy 9 times. 2, 3, 4, 5, 6, 7, 8, 9 times. Okay, and then let's change something like 1, 19, 20, 21, 20, 21. Okay, 19. 18. Okay, basically, which I'm not going to change it. Eventually, we just offer demonstration, so we don't bother to make it that way. Okay. So let's align. So this one create an array in Java. Okay, so second one Brian A B. Okay, and C Carol. Okay, D Daniel. And then Irene. And then F Blake. G George. H E D. Okay. I read. Okay, whatever. I don't know about the name so much. Okay, so these are baseball players creating an array, and we create a baseball team and using the players. Okay. Baseball. Wait. Baseball. So baseball. Okay. Yankees. Okay, and then just print that out at 9. Okay, so Yankee team. And this one is also has a relationship with it. That's it. Okay, so far all has a relationship, and we print out the whole listing of the baseball player. Okay. Okay, so that's good. That actually is good. Okay, this is whole has a relationship discussion. Okay, two types, one type use, one type really has a. Now let's actually try another one called basketball. Okay, so this is a basketball team. I'm going to use its a relationship. So I'm going to put this one here. I'm going to create it. I'm going to do extend what? Array list of players. That's it. This one has a relationship. That's it. Actually, I do nothing. I just put comments. Okay, this create. So basically, this one create a relationship of this basketball team inherit the array list of players. Okay. Now let's actually create another one. We'll test basketball. Okay. Test basketball. And then let's actually copy the whole thing over. Okay. I'm going to change it later. Okay. I'm going to change it later. So don't worry. I'm going to change it later. Okay. So this one like that. Okay. So here I'm going to change it later. So I create a new class called basketball player because player and basketball player are not compatible. So let me actually also copy the player class. I'm just trying to save time. Okay. Okay, so here that's actually don't do betting average, called field average. Okay, so field average because your field goal average. Okay, how much percent he hit the field goal instead of betting average. Okay, and this one is BK player. Okay, so fine. And then let's actually change this one. This one is actually creating an array, but this one let's change to BK players. So let me use a Control F. Change players. Next, okay. Replace with BK players. The once. Vehicle. Okay, PP. Okay. Let's delete these two lines. Okay. And then vehicle average may not be this low. Okay, so let's have something different. Okay, so we create a BP players. Actually, we do not need 9 players, we need 5 players only. Okay, and then we will create a baseball team. and you use a PK players. Okay, so let's try our San Francisco Warriors. Okay. And you can load the player array into the array list. Converting your array to list and loading it into the Warriors, okay, and system.out.println print now Warriors, okay, and run. It also finish, okay. And the good thing about this is that the baseball player is that it's just a extension. You do not need to define its data field. You can, but you do not have to. So it's very clean design because okay, I'm sorry. This one actually I'm using a list. Okay, I'm using a list. So let's actually try another one. This one, let me use a basketball team. This one, let me try another one. Okay, this is what other team we have. Actually, let's actually use Lakers. Let me put in the same array, okay? Okay, so this one, Lakers. I need to, this one actually, create this one. No, let's actually create, okay? Lakers, okay. And then I need to add the player into it, okay? So, for integer I equals 0, I less than pv.length, okay? I includes, okay? And then Lakers at pv's highest member. Basketball. Oh, I'm sorry. The BK player here. No. This one should be BK player. Okay. I'm sorry. BK player. Okay. This is fine now. So let's do this one. Okay. So this is a test basketball player. We test two kinds. Okay. One kind is we use a warrior, but the warrior actually is already a BK player. And the other kind is like Lakers, and Lakers is using basketball. So basketball class is one kind of already so the BK player. So when you use a basketball class, it's the same as you are using the already class. Is that okay? You don't need to add a function. This add function already given by the array list of the PK player. So this is the convenience of using the is a relationship. You inherit the function from your parent class. Is that okay so far? So you can remove a player in case that you want to remove. You will replace the remove. You can remove 2 index 2 part, and then you print it again. You print again. You remove one player, and then you print it again. So Carol got removed. Okay, and you do not need to add new function to it because the array list of PK player already give you the add remove set is empty function, all kind of function for you. Is that okay? Is that okay for this is a relationship? Because basic team is already some PK players. You can use the basic team in a way that you use array list of PK players. Whatever array list of PK player can be done, you can be done with the basic team. Okay, that's the magic of the is a relationship. So let's discuss what is the advantage of the is a relationship when we use array list compared to we use an array for baseball team using has a relationship. Which one is better and why? Okay, Jeffrey, can you comment? Which one is simpler?
It's simple.
Yeah, simpler.
I would say the association has a relationship. But
Simpler, I think the basketball is simpler, right? Compared to baseball, you need to redefine the
oh,
class.
I see what you're saying.
Is that okay? You need to rebuild the constructor. So basically, in terms of simplest, using is you directly take over all the function you have from the array list of the PK player. So it's actually simpler. But in terms of customization and flexibility, this one, you customize everything, even to string function, right? This one, where is the toString function? The toString function is given by array list of PK players, right? Is that okay? Hi, Brendan, do you have comments? Any comments or question? So try to understand the difference between has a relationship and is a relationship. If you are good at this, you will know how to use OOP well, okay? Okay, so these are the difference. I use this BlueJ just because that it gives us the graphic interface, and you can see that very clearly. Okay, you can see that very clearly. So let's look at another case for is a relationship. So let's create a new class. This new class called rectangle. Okay, let's look at the rectangle. Today I'm emphasizing on the has A and is A relationship, okay? So the rectangle may have a private instant data field, double width, and the height, okay? And let's create a rectangle constructor, okay? Then let's have the toString function as well. Okay, this is the toString function for rectangle, okay? So we create a class. You can put the setter getter function here. That's actually just omitted. Okay, let me put it, okay? Let me put it. I may need it. So let me develop a complete class. So you need to have an instant data field, okay? Instant data field. And then you have a constructor. And let's look at the getter setters. Okay, so public couple actually get width. When you build a class, remember instant data field constructors, getter setters. Okay. Following the Panda guideline. Okay. I don't have time to go back to the basic to teach you the whole fundamental class design. Okay. I try my best to show you a single class design. Okay. These are the getter setter for instance data fields. Sometimes you may have derived data field. So the such as okay. Okay, so these are two derived data fields. So we check instant data field. You need to create them. Constructor, getter test setter for the instance data field, derived data field, and then actually overridden function. We do provide two string, and let's also provide another one called equals function. These are basic Java, okay, but I'm sorry, I cannot go back to the fundamental to teach you why these are needed, okay? It takes too much time, but I try my best, okay? Okay, these two overridden function typically when we write a class, we need that, okay? This should be double equal sign to check the equality instead of each single sign for your sign. So usually we develop a class like this with data field, constructor, getter setter for data field, derived data field. Derived data field doesn't exist, but sometimes you use it for some extended purpose. So you treat get area just like get width, okay? And then some overridden function for system purpose, okay? So this is a complete single class design. This usually when you build a class, you need to build like that. Okay, so this one is a class. We finished rectangle, that's fine. Okay, let's actually create another one for tester rectangle. Okay. And let's test it. So rectangle R1 equals new rectangle. Okay, so this one is 3.0 and 4.0. And system that out that point line. R1 that get area. Okay. So this is how you use a function. For the derived data field, okay. Okay, let me move this one on top. Okay, done. Test it. Okay, rectangle. Okay, area that is okay. Good. Now let's actually see. This one is a base class. We would like to talk about the is A relationship. So let's create another one called square. So square is one kind of the rectangle. A square have only one side, one perimeter side. There's no two width and height. Actually, width and height are the same. So rectangle is like this, square is like this. So square, you just use one perimeter is enough, right? So we are going to reuse the code instead of inventing new code. So here I say square, okay, a double side, okay. And this square class actually extend the rectangle. So whatever function the rectangle has now, square has. Okay, and then we call super. Super is to call the rectangle's constructor. Side to side. We use same value for height, width, and height to call the constructor for rectangle. So right now, square is one kind of the rectangle. And then rectangle use width and height. And my square mimicking the rectangle is one kind of rectangle. So we assign this to W. We also assign this to H. Is that okay? By using super. When you call a super constructor, you build another rectangle, but that rectangle's side and the width is the same. Now, okay, so we do not repeat the data field. The data field already saved in the base class. So square would use the data field in the rectangle class. You do not have the actual data field. So that basically, when you build a derived class, subclass, you do not need to repeat the data field. Constructor will redo it. Now, getter and setter. Getter and setter, we are square. We do not have a get width, get height. So that's it. Call this one double get side. Get side is a new function, but we will return actually get width. You can also use get height. It's the same. Okay, because the function is from the rectangle class, and then setter that's actually to call it set side. So when you set side, you actually will have a parameter double side. Okay, but this time you need to update both width and height because your width and height are the same. So actually set width side, set height with side. This one, because you update, you scale your square to be bigger. So you need to update the data field in the width and height. Both should be updated to the new S. Is that okay? Both need to be updated to the new S. Is that okay? And then the next one, your get area, get perimeter is the same. I don't care. It actually, your calculation for the square is the same. Equal function the same. Only to string function need to be modified. So modify this one. Only up to here. These are actually when you can use your parent class function, you use your parent class function. And here we do not have to. We use this side. Okay. Then let's create another one. Oh, just a square. Let me copy the test over. And change to S1. Okay. And now the square function can use all the function from the rectangle, or it can redefine. Or you can redefine the function. Okay. If you redefine the function, you will use the redefine one. So this is a subclass, a class that inherited using the is-a relationship. So basically, is-a relationship, you do have a base class. This base class can be this rectangle class, can be the array list of BK players, and then you actually extend it to the derived class. So right now the derived class is called square. Okay. And the base class is called rectangle. So some code that the square class has is inside the base class, some data field. So derived class is bigger than the base class. Is that okay? Is that okay so far? And we also call the rectangle class as the parent class, and the square class as the child class sometimes. But square class take over all the function and data field from the base class. Okay. And this is the way you write a is-a relationship. Okay. And this one is a reduction of data field because you reduce one data field from the base class. Okay. But let's try another one. Try another class called prism class. So this prism class is different from the square class. Instead of reducing the data field, you extend one data field. Your square is width and height. your prism is 3D. So you do have width and height and the length. I'm sorry.
Yeah.
Let me change it, okay? Let me change it, okay? Let's actually use the width and height. Height right here, okay? Is that okay? So we are going to extend this one. Okay, so that's actually is extension of data field. So that's this one to extend. Still extend rectangle. Okay, you can see that why I'm using Bluejay, Java to explain it, okay? Because it gives you the graphic, I'm sorry, give you the better idea of, okay, so here we have, we have a one new data field called length, okay? So we need to have it. In the square, we do not have a new data field, okay? What is that? You take each 3-dimension data, but two of them you fit into your data field in your parent class, okay? And one you fit into your own class. That's it, okay? So data setters part. Data setter part, you actually get width, get height is the same. You only need to have get length. Area derived function. Now you have area and parameter function. So this you need to rewrite, okay? So basically your area now should be, let's use the surface area for all, okay? So let's do double equals get with h equals get height. X equals x. Okay, and your area should be, you have a surface area, right? So your surface area is width and height, width times height times 2. Right, so you need to return 2 times width times height, width times length plus length times height. Okay, that's the surface area for it. Okay, and then next one is actually getting the parameter. Okay, parameter that's actually count the age here. W times H need to time 4 now. Okay. Plus H need to time 4. So return 4 times. Okay, so these two functions, we define it, okay. Same thing, just copy, okay. Is that okay? We define the divide data field, okay. So getter, setter are new. Get area and parameter function, get parameter function, parameter function are different from your parent class, so you need to redefine, okay? And then, so you redefine it. And now next one, do we need to redefine the equals function and the toString function? Yes, these two you need to override. Because right now you have one more data field. You can no longer use the rectangle functions equal function now. So here change the rectangle to reason. And because the width and height data field is from parent class, you can no longer use the width and height, you use the get width function.
Is on that
Yes,
other
question.
function, get perimeter. Is there any way that you could get the W and H and X from that other function, get area?
And
Because you're declaring a double in both the functions, but they're the same.
what?
So in perimeter and get
Mhm.
area,
Mm-hmm.
you're using the same variables. And I wondered if there was any way you could pull.
No, this is just for convenience.
Oh, yeah, but I just wondered if there was a way you could pull it from get area.
You need to put the get width. So you can get width here. You do not need to declare it. But I declare it just because I want to use a shorthand.
Oh, okay.
WH. Yeah, you know what I'm saying?
Mhm.
I just want to use the shorthand. So now you have one more data field to check because you have a length to check. Is that okay? That's just for convenience of the writing this. Otherwise, you need to use a get width plus get height plus get width, get height, get length, you know, so.
Mhm.
Okay, so this one compared to Prism, okay? Compared to Prism is too long, let me get it done, okay? Okay, so this toString function no longer can use, you need to use Prism. So here you no longer have the width. Okay, done. This is my new Prism function, Prism class. So let me actually create a tester now. You see, when I build these different classes, just like I'm building the Lego, right? You use a very systematic way to build it. This is object-oriented programming, okay? So here, let's actually do Prism D1, 3, 4, 5, and then D1, D, okay, it's called get parameter. I'm going to change. Okay. Let's go back to change the name for the parameter. Let's be consistent. Compile the same as compile. Okay. Yeah. So you see, this one show you the inheritance of deduction of one data field and the expansion of one data field. And we organize this way in OOP, object-oriented programming. So what is the main advantage? Anyone know? Main advantage. For using OOP.
Code reusability.
Yes, code reusability. Okay. It can be reused. Okay. And so basically you are based on the inheritance and also has a relationship and is a relationship. You build up the object-oriented library, usually graphic library, okay? A big graphic library for people to use. We sometimes call it API, okay? Here I can demonstrate only up to here, okay? Here you can continue to write a whole graphic user interface based on it, but we actually don't have that time, okay? Let's see what time we are now. Okay, we are 1 hour. Well, I'll go longer today, okay? I'm healthier now, so let me actually try go through the slices, okay? And you have some water. Okay, let's go through the slices. Today, we basically go over the relationship of class-to-class relationship, is a relationship and has a relationship, okay? Single class design, we have encapsulation, inheritance, and polymorphism. We talked about it before. Today, we emphasize on this class-to-class relationship that is a relationship and has a relationship. We use a baseball and a basketball team to demonstrate it. There are extra topics such as interface, abstract class, and function closure. We'll go through the slices, okay? So objective is to try to understand the OOP, okay, completely. And Python does not have interface. Python uses duck function and type inference. So these two topics will also be included, okay? We'll talk about it later. So we will know about what duck typing is, okay? That's a different story. And so here it gives you the guideline of what OOP is, okay? So including the class-to-class relationship, inheritance type, functional closure, and the duck function, okay? So this encapsulation, I don't repeat, okay? Encapsulation, we talked about it already. And then public, protected, private, I think in the last week, we covered it already. So no longer talk about this, okay? In Python, you create a new class. Your data field is put into the self dot, okay? And a static function put here. We step data, I'm sorry, class variable put over here without cell. Okay, that we talked about it before. So this one is construction of a class. Okay. And to string function, you use underline str using the magic function. This we covered before. Okay. So that one we a private data field using to underline. This in Python we talked about it already. Okay. So that's just review. Class to class relationship. So your class to class relationship, you have two kinds. Is A and has A relationship. So we go through faster. Okay, we don't. So here, class to class relationship, you will have has A relationship. We call it association, and there are different type of association. One to many, many to one, and also self-reference type. Okay. So passenger airplane has passenger. Okay. Airplane has passenger, and airplane step can also be airplane step. So these are self-association. Okay. Library has book is made of books. So this one is also has a relationship. Okay. Library has book. So this portion, this whole thing actually has a relationship. Okay. Bank account is one kind of fixed account. So these is a relationship. Okay. I'm sorry. The last one is not is a relationship. This one is use relationship. Printer setup use the printer. So this one is also has a relationship. Okay, we just review the idea. Okay. Okay, so that's the inheritance. We talk about too much. So mammal, dog, and cat. Cat is one kind of mammal. Dog is one kind of mammal. And then we call the mammal a superclass, base class of parent class. Okay. Dog actually is a subclass, derived class, or child class. One thing is this is single inheritance. Single inheritance means that cat only inherited mammal, but sometimes your cat can inherit two parent class. Then that's called multiple inheritance. Okay, then that's called multiple inheritance. So the proto Pluto are dogs. Okay, but the Labrador is inherit both Pluto and the Labrador. So this is called multiple inheritance. Okay. In Java, multiple inheritance is not allowed. But Python and the C++, multiple inheritance. Okay. Okay. So you need to know about your language. Okay. And what's the advantage of doing this? Sometimes your Labrador can behave like Pluto's. Sometimes it can behave like Labrador. Okay. Okay, so base class give you the base function of base data fields. Derived class can add more, or sometimes share some data. Okay, we talk about it by giving you the square and prism class. Okay. Okay, so basically, when you define the inheritance rule, if you are in Python, you don't use extend, you use a parenthesis and then put the parent class here. So your C1 extends object. Okay, this is how you write it in Python. Okay. This is how you write it in Python. You extend, you use it. I'm sorry, you extend it. Okay, you inherit it. Okay, other than that, we don't repeat. And you can override a function from your parent class, just like we show you in Python, in Java. Okay, rewrite it so you can your animal. Okay, and your dog. Dog is one kind of animal, so you may add more data fields such as data 3, data 4. So animal has data 1, data 2, and your dog has data 3, data 4. Okay, and here your animal has a function of move and eat. Here your dog also have redefined the move and eat. So when you use a dog, you will use the move and eat here. Okay, but if you use animal will use these two. Okay, but sometimes your move can call your. Sometimes your dog's move can call your parent class move function. Okay, sometimes. So this relationship of the overridden function. Okay, mixing multiple inheritance. So you can have the multiple inheritance. So you take over your two parent class feature. Okay, your two parent class feature, just like the Leopoldo-Dudok. Okay, just like this Leopoldo-Dudok. Okay, Leopoldo-Dudok. You take over the feature 1, feature 2 from Leopoldo and take over feature 3 and 4 from Puto. Okay, it's possible in Python and C++, but this is not allowed in Java. Okay, and then if you want, sometimes the function is of the same name. Sometimes say eat or move, they are the same name, so they will use the so-called method resolution order. This one very important. You need to study it. Okay, there's special way to determine which function you call. If both has the move function from your parents, should you use the A's definition or B's definition? It really depends on which one you use. It's called method resolution function. Okay, you need to study the slides. I don't have the time to go over it. Okay, so method resolution function new style is based on the base class. Its base class do not have the definition. You check your second parent. Your second parent doesn't have it. You try your. I'm sorry. You check your own class first. Your own class first doesn't have a function. You check your first parent. Your first parent doesn't have it. You try your second parent. Your second parent doesn't have it. You try your grandpa. Your grandpa doesn't have it. You try the object class. This is a so-called method resolution function. When you have move function, if you yourself you do have a move function, you call yourself definition. If you don't, you try your first parent. And first parent and second parent, how to determine it? It actually depends on your child class. When you define a class, your first parent is here, second parent is here. Okay, so you try the first parent first. So this is called method resolution order. Okay. And before we define the whole system, we define these different object relationship. Okay. Usually we define a few things. class diagrams. Data flow diagram. And also control flow diagrams. Sometimes it's also called a flow chart. When we do system design, before we go into individual class design, okay? So data flow diagram need to depend on the classes. So you define the classes first, okay? So rectangle, square, prism, oval, circle, and ball, okay, sphere. So you conduct the necessary classes that you need to have, and then analyze it into data flow. Which data is the source? Which data is the sink? Which data is the processing stage? Okay, and then develop your flow chart to control your data flow. Okay, these are standard system level design diagrams. Okay, but in OOP you design a class first. Okay, who inherit who? Okay, multiple inheritance is allowed. So super function is to call your parent constructor, okay, or parent function. It's used differently from Java, a little bit different. It's used a super to call your super class, and your super class you can call super underline init to call your parent class. So this one is the way of Python to call super constructor. Is super to find a super object, and then super class, and then call the init function is a constructor for the super class. Okay, compared to Java, it just uses super. Java uses super to call a super class constructor. Here in Python, you need to use super parentheses, comma, init. Okay, this is the same, just different language. Okay, so memo extend object. Memo extend object. So doc extend memo. So this one is actually to call the constructor for the doc for the memo function. Okay. So you actually call memo and a name doc. Okay. Okay. So you can call it using this way, using super instead of memo.list. Okay. Okay, these are okay, simple inheritance. And you may have a structure like this, okay? Memo extend. So super class is animal. Memo extend animal. Okay, non-weak memo extend memo. Okay, non-marine memo extend memo. Okay, and dog extend both non-marine memo and no wing memo. And then create one object called d-dog. And then you can print. And bat actually is one kind of non-wing memo.
Okay.
Wait, sorry, you actually should have a wing, okay? I'm sorry, but just remember non-marine, okay? I'm sorry. This bat should be on this side, okay? I'm sorry. Let me change it, okay? Let me change the slice. I put it in the wrong location. It should be here, okay? Sorry, okay. I'll update the slices. Okay? And then when you call, you'll get output like this, okay? just to show you how this multiple inheritance can be done. Okay. I'll update the slides. So you will call the constructor based on the order of these, okay, one by one, using the so-called measure resolution order. Okay, this is command line. Let's avoid, we don't talk about it. Matching variable are the, okay, these grouping functions are very important, okay. Star arguments and the star keywords. Okay, let's talk about these functions. Grouping of the parameters. Sorry, today may be longer. Is that okay? If you are tired or you have other things to do, you can leave, okay? But today I'm going longer. In a way, I try my best to show you coding by coding itself, okay? Try not to just talking about theory. Theory, you can look at the slides. Okay, let's use the lecture 6. After class, I'm going to send you this sample code, okay? So grouping of the data is important. So let's do actually array input. Okay, array input function. Let's actually try to show you the advantage of ARGS. Okay. Okay. Let's assume that we do have a defined function. We try to find the maximum of the x and y. Okay. So this one return, okay, x if x greater equals y else y. Okay, so this is maximum function for two numbers. Okay, so a equals maximum for the 3 and 4. Here is a conditional statement. Okay. So basically, when we compare maximum for two numbers, this is okay. But how about three number? How about four number? Three number, you can put three number there. How about four number? How about five number? How about 10 number? Okay. Then how about unknown length of the array? Okay. So basically, that's the need for using the maximum star arguments. Let's assume that we only compare the main positive numbers, okay? Okay, so this one actually give you a using star arguments. Okay, so let's try. Let me comment now this function now. Okay, so A equals NP. One number, two number, okay. Three, two number, okay. It's called grouping of the data, okay? Grouping, no matter it's one number or two number, okay, you group them together. Oh, I'm sorry, I should not do this. I'm sorry, I should not do this. Okay. Let's just put one number there. I'm sorry, I tried to represent in the wrong way. It use it to prove it, okay? I'm sorry, I tried the wrong way. But it's okay, let me modify it. The ARGS will group everything together into a list, okay? And that's wrong. It's okay? Let me give you the call to check, okay? The call is like, no matter how many number you have, you group using the star ARGS, you group the whole multiple data field into a list, and you operate the ARGS just like the list. Is okay? This is called arguments. This is called arguments, okay? Argument, grouping argument. Keyword arguments, okay? Keyword argument, double star. Keyword arguments used when we try to do this. So that's actually called keyword argument. Keyword argument you group into dictionary instead of grouping into a group into you group into, okay. So that's H2 S equal next student. See. One moment, okay. Okay, so this one is grouping your key value pair into a dictionary. Oh, I didn't save it. Okay. Save it. Okay, you group into the dictionary. Okay, this one single star, you group into list. Okay, you group into list. Double star will group it into a dictionary. Is that okay? Any question? These are just two function, two way to write we so-called call it what? Grouping of the parameters. Star and the double star is grouping of the okay, so we call it call by tuple or call by dictionary. You can provide your data as a parameter as a dictionary into your function. Provide as a list into your function. Okay. Any question? Using the non-parameter list, but using the tuple and dictionary to put it. Okay. So that's okay. Then abstract method are method that is incomplete. So sometimes you have abstract class, you have function that you don't want to implement yet. We call it abstract class. Okay. An abstract class, usually when your class is an abstract class, you have incomplete function and you define it just because you want your child class to implement it. Okay. You want your child class to implement, and we use an abstract class. Okay. And you need to there are two ways you can create abstract class. You basically you basically declare some object operations, okay? So this excuse object operation, you pass to object methods, and then this one, the excuse will not be implemented in the class, but its child class will have to implement, okay? Anyway, this one we don't talk about it too much, okay? And then instance interface. Interface is also a kind of an object class, but it's even smaller. It doesn't have the data field, okay? Doesn't have the data field. So this portion we don't cover it too much, okay? Polymorphism we don't repeat, okay? So this one we just pass. Let me see. Let me pick up the more important topic, okay? Introspect is too difficult. Let's talk about duck typing, okay? Duck typing is the interface for duck typing is the system for the Python in terms of interface. In fact, the Python does not really have the interfaces. It used the so-called duck typing. Okay, so duck typing is a feature of the type system where semantics of a class is determined by its ability. So see what function you have, and then you decided that actually is one kind of something. It's called duck typing. Okay, so duck typing is the way of doing interface in Python. Okay, so someone who actually look like duck, swim like duck, and quack like duck, then is probably a duck. This is called duck typing. So officially, it did not declare interface relationship. Okay. Officially, it did not declare interface relationship, but actually, we call it duck typing. This is a little bit hard to understand now. Let me go back to Java. Okay. To talk about interface. So here we do have a rectangle. Let's actually create another class called oval. So oval is a class that actually is similar to the rectangle. So let's actually copy the rectangle's body, the whole thing. Okay. Let me copy everything from rectangle to oval. Okay, so right here, actually, oval do not have the width and height. Oval is like this. So there's a long axis and short axis, A and B. Okay, half axis. So let's just do this AB. Okay. So let's actually have A and B. Okay. So here let's do oval. So right here, let me do quickly. Control F, all of the width, lowercase width, let me replace with a capital A. Once, 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 once. Okay. Now let me go back to here. This time, let me use the height. Let me replace with B. So that's once, 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 once. Okay, now this one I need to use lowercase a lowercase b, okay, lowercase a, lowercase b, lowercase a, lowercase b. This is the way I update, okay? Get area, your almost area is AB pi, so times messed up pi. Parameter, I don't know. Let me see. We check the ovals parameter. Oh my God, it's actually quite long, okay? Actually quite long. Let me try to do this, okay? It may be, is it wrong, okay? Is it wrong? Let's try just to mess up pi times 100, okay? It is, let me put it the wrong formula. It's too long, okay? I don't want to do it. But I do want to show it, okay? Here we need to change it to not rectangle, not to change to oval. Okay, sorry for that. I'm not expert in ovals parameter. But anyway, the things that I'm trying to actually change the from the rectangle class to oval class. So now I want to put them together. So they will be a drawable interface. Drawable interface is an interface sitting on top of the rectangle and oval. There's only one function called draw function, and it actually is draw abstract. Okay, void draw. Okay, this is actually an abstract function. So you haven't implemented it. But this object, you can take it out because it's an interface. You write it or you don't write it, doesn't matter. Okay, you write or let's actually write it. So there's a function that actually you need to implement. If you implement the drawable. So here let's do implement. Implement drawable means that your rectangle is drawable. So now you need to draw. You need to draw. So you need to provide a function called actually provide a function to implement to actually implement. So you need to draw. Usually this one is to draw on the 3D graphics, okay? But here we actually just try to do it. So just use the text mode, okay? And here this guy also implement drawable. Okay. So it also had a responsibility to implement that function. Okay, so now I finish. Finish. So there's a drawable, oval is drawable, rectangle is also drawable, square is also drawable now. Okay, now I'm also creating a new class called test. Drawable. So that's actually create an array of drawable. And then we new oval. These are all drawables. So in a way, interface is also grouping the object of different type together, okay? Superclass has the power to group the object of same type together, okay? So interface is a superclass, and superclass can group the subtype class. And so interface is a special type of the superclass. It said that there is no constructor, no data field. Okay. Now we put in things together. It's all drawable. Okay. So let's do this. Or drawable B from DS. Okay. And then we do system.out.print line. No, I'm sorry. Let's do D.draw. Everybody draw itself. Okay. Everybody draw itself. Let me clean it and read on it again. Okay. So the data is the first one is what? The first one is oval. So it print up my oval is prettier. Okay. Rectangle print show a rectangle. Okay. And then oval print my oval is prettier. Okay. Square print show a rectangle. Okay. And then prism print show a rectangle. So now let me go back because I don't like so many people to draw rectangle. So let me redefine the draw function in square. So this is called overriding. Okay. So public. You can redefine the draw function in the square. Okay. I'm sorry, it should not be returned, should be this is the use of interface, okay? And the prism that's also redefine it, okay? Okay, done. And then we use this test drawable test. Let me add the cleanup statement, okay? So this is the user interface. You just wish your child class to perform in the same way. Okay, so if it's always say I'm prettier, rectangle say this, okay, oval say this, square say this, okay. By the definition, everybody implement its own draw function. It's okay. So interface is grouping them together. So everybody in the drawable is one kind of drawable. They all being drawable. They can all be drawn. But they are different type. Okay, they are different type. And this is the idea of using the interface. Interface is a special parent class. Okay. Now duck typing. Duck typing in Python, they don't have interface. They don't have interface, so they say it's duck typing. So duck typing means that there is really no special drawable function. As long as your dog implement the draw function, your cat also implement the draw function, and then this is duck typing. So if duck can be drawn, if duck can have a draw function, and everybody has the draw function, then everybody is a duck. It's okay, but we really do not define an interface on top of it. Is that okay? This is called duck function. If you behave like duck, okay, the idea is like, so there's no official declaration of the interface. Instead, it just use the idea of, if you look like duck, swim like duck, and quack like duck, and it probably is a duck. Okay, that's duck typing. So duck and goose are two objects of different type. They share the same polymorphic method. Say this time they may have quack function. Okay, so it's an automatic interface. Okay, so engine class implement engine, car engine. Let me see. Duck typing. Okay, so car has a wrong function. Okay, I'm sorry, using this function. So duck function, duck has quack and fly. Person has quack and fly. So actually, person quack and fly like a duck. Okay. So in the forest, your person behave like a duck. Okay. So there is no official quackable interface. Your person quack and like a duck, they are both duck. Is that okay?
What is thing?
Hmm?
Thing.
Sin just available. Unknown sin. It can be duck, it can be person.
Okay.
So you pass a duck to there and pass a person to there, it both work. Just like draw function, draw can draw a rectangle and draw a oval or draw anything, as long as it has the function. So this one saying that duck typing is like this is sin, as long as it quack and fly. This function can process any type of the scene that can quack and fly. So you have the dark that can do this, and your person can also do that. This is called dark typing. Is that okay? So as you can see, Java is more organized in this, right? Java is more organized. This one actually just like you have to know that both. Okay. It's just like inherent implicitly, scene can handle both dark and person implicitly. All right. This is the so-called dark typing. Okay. So we have dark can quack and fly, goose can quack and fly. A person can also dark quack and fly, and then they can do the same thing. Is okay? In different way, even though they are in different way. Okay. But they don't have an interface to cover it. In comparison, Java do have a top-level interface, so you know that everybody are drawable. They do need to implement a draw function. Okay, and in Python, no. Python, as long as you behave like me, my function can be used by you. Okay, as long as you behave like me, I drink and eat, you also drink and eat, and then you are me. You can behave like me. Okay, that's a pretty simple idea. So that's called dark typing. Okay, don't get confused, not too hard. Okay, we have a few more topics that's finished. Okay, type inference. Type inference is in language like Python or JavaScript, there is no type. Then it will actually backtrack into the root data field to determine what type it is. Okay, this is called type inference. So say let's assume that here we do have a function foo and bar, and then we do this bar goodbye and hello. So let's assume that we call this function. So this function we call here we do return. Let's see which one we just started. Okay, let's call string. It's a bar function. Okay, so bar function have two strings, goodbye and hello. So these two are string, and then pass to bar function. Bar function would have two string. Okay, and it change it to call foo function. So this one call foo function. So foo function determine x and y both are string. And here this plus sign will do concatenation for string. And then return the value one by one, and then return to port. Okay. So in the processing, how to determine the operation of this one is based on type of propagation, starting to your function call, backtrapping to determine this one is a concatenation. It's not a mathematical sum. Is that okay? This is called type propagation and type inference. Okay. Okay, typing. So basically, Python and JavaScript, depending on this type inference and also for propagation. Usually, this happens on the script language. They don't have type. Okay. So typing is the runtime typing, dynamic typing type. Okay, we call it dynamic typing. You need to determine a typing only when you know at the runtime. Same thing, duck typing is the runtime dynamic typing. Duck typing is a dynamic typing because duck typing, you assume you don't know what type it is. You assume you don't know what type it is, right? Duck typing, you assume you do not know what this thing is. It's called duck typing. It actually is the determine the type, whether it's a duck or is a person. At the runtime, you determine it. Okay, but in Java, we know what type it is because Java's draw function will be will be drawable. It must be a drawable type to be able to draw. Okay, so that's why we call Java as static typing, and the Python is dynamic typing. Okay, so typing is determine the data type, and the Python is determine the data type in the runtime. Okay, last topic, function closure. Function closure is an object that actually pass function as object. Okay, pass function as object. So here we do have a math. We have a zero calculator, square calculator, okay, cube calculator, whatever. So many different calculator type. Okay, and we can run them. Okay, we can run them. This one calculate. Everybody has the calculate function. Everybody has a calculate function, and then you pass through your function to do calculation. Okay, run the calculate. Run the calculate. So this is a little bit like a duck typing. Okay, but you pass the function as an object to it. Okay. What is special here? So basically, when you call, you pass the function that need to be run. So here is a list of a function. So you get every function from there to calculate it. Okay, to calculate it. So here you run calculator for foo, and run this 3 function for foo. Okay, this is a function closure. So you can put your function in the list and then process it one by one to the foo. Okay. Okay, this one you can spend some time to look at the function closure. Okay. I think that's it for today. We are longer today. Hopefully be helpful to you. Okay. Any questions so far? Any questions so far? If not, we are going to be dismissed, okay? And then see you on Friday for another mega session, okay? Thank you for your patience, and then sorry for the miss of 1 week, okay?
Yeah, thanks for going over that chapter.
Are we
Okay,
gonna meet again on Friday? What time?
Friday, same time, noon time.
Same time? Okay. All right.
Okay, bye-bye, see you.
All right. Thank you. Bye.